Hello, NEET aspirants. I am Dr. Shankar, your physics educator, and I welcome you all again on your very own channel, NEET Success Simplified. Guys, in this session, what we are going to do, we are going to solve some previous year questions of NEET examination from this topic of units and measurement. Solving previous year question in any topic is very important, because from solving these questions you will get an idea that how the questions are being asked and whether the content that you are having, whether the concepts that you are having are good enough to solve these problems. Okay, so let's go with the first few problems. So these all are NEET problems. So let's do it quickly, because see, in NEET examination or the competitive examination, it is also important that you do the questions in a less time frame. So the unit of thermal conductivity is, so Q is equal to, so for finding the unit of any entity, any physical quantity, any constant, what you require the formula for that. Okay. Okay, sir, we don't know the formula for thermal conductivity. It is okay for timing, because see, when you are going to proceed with the next chapters, you are going to get to know all these formulas. Okay, so when you know all these formulas, you are definitely going to solve it. Okay, but for time being, I am using the formula right away. Still, you haven't seen it, I know it, but I am using this formula for time being so that you get the process. Okay, so what is K? So see, this K comes from the formula that we are going to use in the thermal. Okay, so Q is equal to Ka dt by dx. Okay, this is the standard expression. So this is heat rate, that is heat energy transfer per second. So what is the unit of this Q? So the unit of this Q is going to be watt. Okay, so right away we are going to do it. Okay, so we are not into a conventional paper, so we do it conventionally like this. We take this K there, that. We are not going to do that. We are going to do it promptly. Okay, so this is K. What is the unit of area? So it is meter square. What is the unit of dt? Dt is the change in temperature, so that is Kelvin. Dx is the change in length, so this is meter. So from here, what is the unit of K? So the unit of K is going to be watt per meter Kelvin. So can I write it as watt meter minus 1 Kelvin minus 1? Is it fine to you? Yes or no? Yes, sir, absolutely. So what is the answer to this problem? The answer is D. Okay. Now moving to the second question, very interesting question. Let's read the question. So the density of material in CGS system of units is 4 gram per centimeter cube. In a system of units in which unit of length is 10 centimeters and unit of mass is 100 gram, the value of density of the material will be. Now, what does that mean? So basically, we know in CGS system, we do by the units of centimeter and gram. Okay. Now here they have introduced you a new unit in which we are taking a standard of 10 centimeter and 100 gram. Okay. Okay. So other than the centimeter and gram, we are using the standard of 10 centimeter and 100 gram. So what is it, sir? What it is? So see, please understand this. So density. Let us first try to understand that what they are trying to tell us in this question, what they want us to do. So let's suppose that we have some density 1000 kg per meter cube. Okay. Okay. And this 1000 kg, I want to convert it if it to gram. Okay. You will be writing, sir, 1 kg we know we have 10 to the power 3 gram, that is 1000 gram. 1000 gram. Okay. Okay. And this meter cube is having 1 meter having 100 centimeter. So we can write 100 to the power 3 centimeter cube. Okay, 100 to the power 3 centimeter cube. I hope it is fine to everyone. Now, think in a way that if this whole thing, if I say that we are using 1000 gram and 10 to the power 3 centimeter cube as the standard of unit. So we can call it as kg per meter cube, right? What I'm trying to tell you that any number, so any physical quantity is represented with the help of numerical value and the unit. Now unit you can choose by yourself that whether you want to show in what units. Okay, so here in this question they are telling us that in a system units in which unit of length is 10 centimeter, unit of length is 10 centimeters, so they have given you 4 gram per centimeter cube. Okay, and we want this value, in the unit of length, that is 10 centimeter, and that is 100 grams. So what we can do, can we write it like this? 4, now please understand this, so we want to represent it in 100 gram and 10 centimeter. So 1 centimeter cube we can write 10 centimeter cube. Okay, okay. Sir, how we can do it? So we can't do it. So what we are going to do? So we are going to multiply a 10 to the power 3 here, just using the basic aptitude, basic common sense to solve this question. Okay. Otherwise, it will go very long. Okay. So we want to save some time as well. So we are doing this way. So this is 4 into 10 to the power 3. This is 100. So can I divide it with 100? Yes, sir. Very sure you can divide it 100. Now, if I see in any equation, if I multiply it by 10 to the power 3 and divide it by 10 to the power 3, same way, if I multiply it with 100 and divide it with 100, the expression remains unchanged. So what we are going to get? So 4 gram per centimeter cube. So from here, can I write? See, 10 to the power 3 upon 100. So it is going to become 40. And this is 100 gram per 10 centimeter cube. 10 centimeter cube. So now what is going to be the answer to this question? So if 4 gram per centimeter cube is represented in the unit of 10 centimeter length and unit of mass 100 gram, okay, that means 10 centimeter is one standard unit. You can name it anything. You name it Rahul. Anything you can name it. No matter. So 10 centimeter and 100 gram. That means one standard unit of length is now 10 centimeter and one standard unit of mass is 100 grams. So what we are getting, sir? We are getting this 40. We are getting this 40. Now let's come to the question number 3. Okay. So let's read this question. So the question number 3 says that the unit of permittivity of free space, the unit of permittivity for free space is, so what is going to be the unit of this permittivity? Okay, so for that we require the formula of this permittivity. So the formula of this permittivity is what? So again, we don't know it, so don't worry. When we are going to see this, you are going to know it well. So this is going to be Q square upon R square upon 4 pi F. Okay, this is the formula of the permittivity of the space. Don't worry if you don't know it now. When we proceed with our chapters of the physics, you are going to know it very soon. Okay. So from here we can write the unit. So what is the unit of Q? So the unit of Q is coulomb. Okay. Okay. So coulomb is the standard unit of this Q. So is coulomb a fundamental unit? No, sir. It is not fundamental unit. It is a derived unit. Okay. We know that. Now this R square, so what is the unit of R? Represents some sort of a length. So this is meter square. What is the unit of this 4 pi? The unit of this 4 pi, it is dimensionless, so it is a constant, it is a number. And what is the unit of this force? Force unit is N. So what is the unit of this permittivity? It is coulomb square divided by meter square and Newton. Okay, meter square Newton. So coulomb square Newton meter square. So what is the option? So we are getting the D option. We are getting the D option. I hope it is fine to everyone. Right? We are getting the option as D. Now let's move to the next question. So the unit of Stephen Boltzmann constant. Okay. So all these are previous year questions. Now you can see that these questions or these sort of concepts we already have discussed during our academic sessions, during our discussions of these chapters. Okay. Now, what is the unit of Stephen Boltzmann constant? So you guys can solve it. Guys can try it, but sir, we don't know the formula. Okay. So I'll tell you. The Q is equal to sigma into A into T to the power 4. This is your Stephen Boltzmann law. It is used in the radiation. It is used in the radiation. So sometimes it is written as Q, sometimes it is written as E, all are the same thing. Okay, so what is sigma? Sigma is the Stephen Boltzmann constant. And remember, Q is the rate of heat transfer, rate of heat energy transfer. That is, it is again in the unit of watt. Okay, what is watt? Watt is again a derived unit and it represents Newton meter per second. I hope we know that. Okay, Newton meter per second. So right away what we can do, so this is watt, this is sigma, what is the unit? So I'm just writing the units. Okay, so simply, okay, so we can just answer like in a snap. Okay, otherwise we are going to follow the whole conventional way. It is going to take a lot of time. So this is watt sigma meter square. Temperature, for temperature it is Kelvin to the power 4. So what is the unit of this Stephen Boltzmann constant? So it is going to be watt meter square Kelvin to the power 4. Watt meter square Kelvin to the power 4. So let us match the option. So we are getting this as A option. We are getting the A option. I hope it is fine to everyone. Okay, I hope this is fine to everyone. Now, sir, let's move to some more questions. Let's move to some more previous year questions. So let us have this. Let us have this. Okay. So we are having, please observe. So I'll give you some more questions. No worries, just some. Yeah. So here. Yeah. Oh, it is rotated. What happened? It is getting some angular velocity or what? Right. Let me get it for you. So we have this question. Okay. Okay. Now it's what it says. So it says if x is, now read this question. If x is 80 plus bt square, where x is the distance traveled by the body in kilometers and while t is the time in seconds, then the unit of b is. Then the unit of b is. So what could be the unit of b from here? So guys, before I solve it, please pause the video, or if you are live, you can answer it now. Okay. Okay. Otherwise, please do solve before I solve this question. Okay. I hope you are doing that. So x is equal to 80 plus bt square, where x is the distance traveled by the body in kilometers, while t is the time. So x is equal to 80 plus bt square. Okay. Now, from the principle of dimensional homogeneity, each of the term from left hand side to right hand side must have the same units, must have the same dimension. So what is the dimension to x? The dimension to x is L. What is the dimension to this? It must be L. And what should be the dimension to it? It must be L. Okay, it must be L. Okay, it must be L. So if I write dimension of b t square is equal to L. Okay. Okay. So this t square is what? T is the time. Okay. So it is t to the power 2 and this is L. So what is the dimension of this b? So dimension of this b is L t to the power minus 2. And we all know that what is the right meaning of dimensions? So dimensions are the power to which a fundamental dimension or fundamental unit is raised to express any derived physical quantity or derived unit. Okay. Okay. So LT minus 2. So here, what is the unit to this length? So length unit is given to be kilometer, and for time it is second. So kilometer second minus 2, that is C option, kilometer per second is square. I hope it is fine to everyone. Okay. Now let's move to the next question. I hope you are enjoying this session. So this is the question of 2020. So all these, as I said, are previous year NEET question. Okay, so see how many. If we understand this, we are going to have the 4 marks when we solve this. So, what does this question say? So, this question says the dimensions of stress are m L to the power 2 t to the power minus 2, m L0 t to the power minus 2, m L minus 1 t minus 2, and m L t minus 2. So, we know the formula of stresses. So, how can we define, how can we formulate the stress? The stress is given by force upon area. Okay, so you are going to see this term when we'll be studying the solids. Okay, the properties of the solid. So, what is the dimension of this force? So, I told you to remember this now. So, what is the dimension of the force, sir? It is mlt minus 2. What is the dimension of this area, sir? This is L square. So, what is the dimension of the stress, sir? It is going to be ml minus 1 t minus 2. So we are going to have C as the correct option for this question. I hope it is fine to everyone. Okay. Now let's move to the next question, or the next questions I may say. So now let's try these questions. Okay, so here we have three questions together and we may try to solve them. Okay, so before I do, you must always try to solve these questions, right? Okay, so lastly we have found this. Now each of the questions, so we have how many questions here? We have three questions here, and each of the questions we are supposed to solve. Each of the question we are supposed to solve here. So now let's start with the first question. So it says if energy, that is E, velocity V, and time T are chosen as the fundamental quantities. So we know the fundamental quantities are the seven, but here for a change, they are six. These kind of questions are asked a lot. So if energy, velocity, and time are chosen as the fundamental quantities, the dimensional formula of surface tension will be. So what is going to be the dimensional formula of surface tension? Let's solve this question. So now, first question. So, sir, we know the formula of surface tension. We know the formula of energy, velocity, time, etc. So, one way could be you can check each of the option. Okay, you can first get the dimension of the surface tension and then can check each of the options with their dimensions. So, whichever matches, then that would be your answer. But that would be a lengthy process to do. So what we can do, we can use the principle of dimensional homogeneity. So we can say that the surface tension, let's call it S, is proportional to e to the power x, okay, v to the power y, okay, like the way we have solved previously. So in this way, we have formulated the relations between the physical quantities, and S is proportional to t to the power z, t to the power z. Now, what we can do, so if I write all of them together, I can have a constant of proportionality, and this is going to be e to the power x, v to the power y, and t to the power z, right? Right? So what we can do? So we can have the dimensions. We can have the dimension on both the sides. So we have learned to do so now. Now here we want to find the dimension of x, y, and z. So what we can do? So what is the unit of, what is the dimension of surface tension? So sir, we don't remember it. No worries if you don't remember. So surface tension is force per unit length. So what is the dimension of force? Sir, it is mlt minus 2. What is the dimension of length? It is L. Okay, so the dimension of surface tension. Now, K is a constant, so we have nothing to do with it. What is the dimension of energy? Sir, it is Newton meter. So for Newton, it is mlt minus 2, mlt minus 2, and meters, that is force into distance. So we can have one more L. So we can say ml square t minus 2 to the power x. Now for V, it is lt minus 1 to the power y, and for t it is time, so it is already z. Now here I can write from left hand side as mt minus 2. We can write as mt minus 2 is equal to, now I'll be doing one thing. I'm going to do what? I'm going to compare the bases or the powers of the same bases on the left hand side and the right hand side. So m to the power x, L to the power 2x plus y, and t to the power minus 2x minus y plus z. So from here, what can we write? So we can write from here that so x is equal to straight away 1. How come, sir? So if I compare the bases, I can have x is equal to 1 right away. I can have x is equal to 1 right away. Do you agree or not? Okay. Okay. Now we can say that 2x plus y is equal to 0, because here on the left hand side I can write it like this also, na? L to the power 0. So if I compare the bases, I'll be getting 2x plus y plus 0. 2x plus y plus y is equal to 0. So from here x is equal to 1, so y is going to be minus 2. Now let's see if any option matches by this. So 1 minus, no. So this can't be the answer, this can't be the answer. So sometimes we have to go through the options also sometimes, because now by doing this even we can come down to the right option. So why to waste time further, right? In the examination, we must be very, very smart while solving the question. Now for t, it is minus 2x minus y plus z is equal to minus 2. Is equal to minus 2. Okay. Now putting the value here, so it is minus 2, x is equal to 1. Y will become minus minus plus 2 plus z minus 2. So what are we going to get? We are going to get z as minus 2 here. We are going to get z as minus 2. So if we put this into this very equation, so we have s is proportional to e to the power x, so x is 1, v to the power minus 2 and t to the power minus 2, because y and z both are minus 2 only. So let's see if we are having any option matched here. So is any option matching here? So yes, B option is matching. Exactly, e v to the power minus 2, t to the power minus 2. I hope it is fine to everyone. Now moving to the next question. So see, all these questions, all these concepts we have learned during the live sessions, during the sessions. So if you haven't watched those sessions yet, please go and watch all the sessions on units and measurement. And these questions you will find very easy then, if you have good concepts, if you learn those concepts. Now, if dimensions of critical velocity, I'm reading the next question, of critical velocity of a liquid flowing through a tube is expressed, tube are expressed as eta to the power x, rho to the power y, r to the power z, where eta, rho, and r are the coefficient of viscosity, density, and radius of tube respectively, then the values of x, y, z are given by. So nearly it is the question with the same, same line, okay, or same direction. So here what it is said, question number 2 of this. So critical velocity, okay, critical velocity is given as a function of, so can I write k times eta to the power x, rho to the power y, what else is given? R to the power z, r to the power z. Okay. Okay, so we need to find we need to find the value of x, y, and z. We need to find the value of x, y, and z. So again, we can use the principle of dimensional homogeneity, and we can write the dimension of the left hand side and the right hand side term, and then simply we can find the values of x, y, and z. Okay. Okay, so here, what is the dimension to this velocity? So this is LT minus 1, we know. Now, K is just a number, it's a constant. So either you write it, you don't write it, that is same thing. Now, so we don't know the dimension of dynamic viscosity. So for dynamic viscosity, we have shear stress is equal to mu times du by dy. So sometimes it is given by nu, sometimes it is given by mu, sometimes it is given by anything, but the coefficient of dynamic viscosity, we are going to see it when we are talking about the properties of fluid. There we will be seeing the Newton's law of viscosity. So from the Newton's law of viscosity, we can have this formula. So from here we can get the dimensions of this eta. So what is the dimension? So we can first get the unit if we want. So what is the unit of the stress? So it is Newton meter square. What is this dy? Dy is change in length. So it is going to be multiplied by meter. And what is du? Sir, it is velocity. So it is meter per second. So what is the unit of eta? So the unit of eta is going to be Newton second per meter square. Newton second per meter square. Now let me get the dimension of it. So because it is quite large expression, so it is always advisable to get the dimension beforehand. Otherwise, if you right away put it here and then you will do, there are a scope of confusion. There is a scope of silly mistake. So let's sort this out. So what is the dimension of Newton, sir? It is mlt minus 2. What is the dimension to the second, sir? It is t. Okay, it is t. So I'm just writing the dimension for time being. Okay, and we have meter square, so this is L square. Okay, so from here right away we can write here, so LT minus 1. So here, so let me do it once in the on the next page. Let me do it, because see, otherwise it is going to be clustered. You are going to get confused. So we have LT minus 1 on the left hand side. Then what is the unit of this eta? So the unit of eta is going to be, so we have the m. Okay, we have L minus 1, L minus 1, and we have T minus 1. We have T minus 1. So this is going to be the dimension of it. And what is this power? This power is x. Okay, this power is x. Then we have rho. Rho is what? Rho is density. It is given in the question, and this is the general representation of the density as well. So the density, we understand, it is ml minus 3, right, kg per meter cube. So ml minus 3 and to the power y. Then we have r. So r is dimension. So dimension, that is L to the power z. L to the power z. So here I can write. So on the left hand side I can say mlt minus 1. Here we can have m to the power x plus y, L to the power minus x minus 3y plus z, and t to the power minus x, t to the power minus x. This is how we can we can formulate the equation, right? We can formulate the equation, right? Right? So from here what we can do? From here what we can do? And I hope all the students watching this video, or all the students who are live in this session, they are attempting these questions beforehand, before I solve them. So from here I can say that x plus y is equal to 0, just matching again the powers of the bases. So x plus y is equal to 0. Then we have minus x minus 3y plus z is equal to 1, and we have minus x is equal to minus 1. Simply we are equating the powers of the same basis. Like we are equating t to the power minus 1, t to the power minus x. So minus x is equal to minus 1. So x is equal to 1. Now let's see if any option is getting matched. Also very unlikely. But I can assure you that B and A are not the option. B and A are not the option. These are out of the option. These are out of the option. Right? Now please understand this. Now in the examination, how you must do it. Now please understand this. Now, if you observe the options, you need not to find Z if you have found Y, because options are that way, right? See, in the examination, in the competitive examination, saving time is also very important. If you save few minutes from a question, you can use those minutes in some other question, right? You can use those minutes in some other question, okay? Okay, so now what we can do, so we can say x plus y is equal to 1. X plus y is equal to 0, not 1. M to the power 0 here, m to the power x plus y. So comparing the powers, I can have x plus y. I can have x plus y is equal to 0. So x plus y is equal to 0. So I am putting the value of x. So y will become minus 1. So what is the option then? What is the option then? So do we need to calculate z also? Obviously it is going to be minus 1, because there no other options are getting matched. Okay. Okay. Now please understand the next question. So if force F, velocity v time t are taken as fundamental units, then the dimension of mass are. Now again what they are asking you in the third question, that again now they have changed the fundamental unit. although these are not the fundamental units as defined in the physics, but for the sake of making the question or for the sake of a change maybe, they have considered this force, velocity, time as the fundamental units, and now they are asking you the dimensions of the mass. Okay, so dimension of any physical quantity is to be represented as the powers to the fundamental quantity. Now fundamental quantities have become FVT. So again, what we can do, so it is the similar question to that of first, second in this series of questions. So we can say, let's go for the third question then. So in this third question, what can we say? In this third question, what can we say? So in this third question, we have force, we have velocity, we have time, then dimension of the masses. So what we can say, the mass is proportional to, the mass is proportional to, what are these? So we have F, V, and T. So we can say that it is proportional to, or we can write equal to right away. No? We can write equal to also, doesn't matter. F to the power X, V to the power Y, T to the power Z. Okay, we can say F to the power X, V to the power Y, T to the power Z. But this it is going to be a little lengthy. So I'll give you one shortcut also. But let's follow the process. See, sometimes getting more shortcuts is also getting likely to confuse us. So we can write M. Okay, what is the fundamental unit? How can I define the dimension of it? So if it is FLT for force, we have MLT minus 2 to the power x. What is VLT minus 1 to the power y? And what is T? Sir, it is T to the power z. So from here, right away we can say x is equal to 1. Okay, now let's check the options first. So F1, so all have F1. Okay, you can't do anything. Okay, so examiners are also smart. Now, not only you are smart. Now x plus y is equal to 0. So y is equal to minus 1. So now let's check the option. So v to the power minus 1. Now we have bottom down that the answer would be either C or either D. The answer would be either C or either D. No worries. So now what can we do? So y is equal to minus 1. Now what is T? So we have minus 2x minus y plus z is equal to 0. Sir, what are you doing? So we are comparing the powers to the base of T. We are comparing the power to the base of T. So what is the power to the base of T? So it is minus 2x minus y plus z. Minus 2x minus y plus z. So from here we can put the value of x. So x is equal to minus 2, y is equal to plus 1, and that is z. So z is equal to 0. So from here z we are going to get plus 1. So z we are going to get plus 1. So that means that this is going to be the option, because t to the power z it is, na? T to the power z it is. So z is 1. So we are getting this D option. We are getting this D option. So I hope it is fine to everyone. So guys, in this session we have done some questions, some previous year questions of the units and measurement asked in the NEET examination. Okay, and all these questions give you how many marks? 4 marks. Okay, so in the one more session, I'll give you some more questions. I'll come up with one more session of previous year questions. Okay, and there we'll solve some more questions of this context. Okay, okay, so we'll be solving some more previous year questions. So in today's session, we have solved 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions we have solved in such a small duration of time. Okay. So for such of these videos, such of these question practice, such of these concepts, please do subscribe our channel, not our your channel. Okay. NEET Success Simplified. Okay. So with this, thank you very much. Have a good day, and we'll see you in the next session.